Hello, this is Dan Alford with ARC Specialties, and you're listening to Dan's Cadre of Experts. I've got a fellow on today that has taught me a great deal in this industry, Dr. Charlie Ribardo.
Thank you for having me today, Dan.
Yeah, Charlie and I got a long history, but let's explain the doctor thing, because my shoulder kind of hurts here. Can you help me with that?
No, I can't help with any of that, Dan. I got a shoulder issue myself. No, I'll tell you what happened, Dan. I'll tell you, people that knew me in high school probably wouldn't expect me to be college bound. But
much less PhD.
Especially end up with a PhD. But I started out as welding as a hobby of mine. I was about 13 years old, started doing some welding around the farm, and it got to be a hobby, something that I enjoyed. Went to Texas A&M and found a program where I could do welding as a part of a technical elective program. And got out, went to work in the oil and gas industry, Hughes Tool Company, and realized that the more I learned, the more I did and the more I learned, there was more to learn. So I decided to go back to school, go to the Ohio State University to pursue a welding engineering master's. And once you get there and you get involved with the program and you get engaged, I just decided to continue on with the PhD.
So both of your graduate degrees are OSU?
Both of my graduate degrees, yes.
How many welding engineers actually know how to weld? It makes you kind of unique, doesn't it?
Yeah, quite honestly, not many. I was surprised myself when I was in graduate school that not many graduate students know how to weld. But like I say,
isn't that important?
It is important. It's really important. It started out as a hobby for me, and it's a hobby for me. Just about not every weekend, but several times a month, I've got a little welding project or two I work on. And it is important, and I'll tell you why. It's because in my job, I end up writing a lot of specifications, working with other engineers to develop welding procedures. And if you can't understand what a welder has to go through to perform a weld, whether it be the repeatability or the parameter control, then you're not going to be as effective writing those specifications. I've read specifications in the past and thought, well, this person's never held a welding torch or never held a grinder in their hand. It's obvious from the work instructions that they're trying to have executed. So I think that having some hands-on knowledge is really important. And I'll say a big part of my success, I think, has been that I have had the practical side of welding and metal fabrication, and then I can combine that with the theoretical side and hopefully get that across in the specifications I write.
My world's exactly the same. You cannot program a robot to do something that you don't know how to do yourself. So. I'm glad to see you know how to weld. So our lives are interconnected. So I think I was a little late bloomer. I didn't start welding until I was 14, I suppose. But then my first job out of school was 1979, Hughes Tool. I moved on. And then you ended up with...
That's right. That vacated a spot. It was you exiting Hughes Tool to start your business that created a position. And I was hired... by one of your previous mentors and mine,
Eric Sullivan,
into the welding lab there at Hughes Tool.
Was that before your graduate degrees?
Yes, that was before. I had finished my bachelor's at Texas A&M and was hired in as a welding engineer there. And that was, again, a spot where I learned a lot and learned that the more I learned, the more there was to learn. And that and combined with the examples I had of my mentors, such as Eric Sullivan, persuaded me to go back to school.
Oh, that's a great place to start. I mean, we were working with every material, every metallic material and a lot of non-metallics, all the advanced processes. What a great first job, huh?
Most definitely. I even got involved running a lot of the furnaces in the heat treat laboratory.
They didn't let me do that.
Yeah, well, we were downsizing at the time, so we were picking up different hats and skills, and so it was a great place to learn, and we had electron beam welding and all types of other manual welding.
Friction, inertia, flash, TIG, MIG, atomic hydrogen, everything but laser.
That's right. We were welding on heavy sections things, so We had the electron beam welding. There was quite a lot of opportunity to learn there.
But we didn't run, our paths didn't cross at that point. But then fast forward later, this is my version of it. Fast forward, you apparently you finished your graduate degrees and you were building armored tactical vehicles.
That's right. So I'd finished up at Ohio State and was looking for a way to get back to Texas. My wife and I had our first son, and we're both from Texas. And I had an opportunity to go to work for Stewart and Stevenson, building tactical vehicles in Sealy, Texas.
Which is 50 miles out of Houston.
Yes.
And then I get a call. I don't know if it's from you or from who, where they wanted to automate.
That's right. I was the first person hired to start a fabrication facility. At that time, Stewart and Stevenson was purchasing parts from all over the country and running them down an assembly line to put military vehicles out off the end of the assembly line. And so we started out bringing parts in, both fabricated parts, machined parts, and we got to a point where we needed to introduce some automation. And I said, I know the place to go. I know the guy to go to. So we called you out, and I remember you coming out that first time to see what we were up against.
But a couple of robots out there.
Definitely. I think it was 4 robots total that you put out with all the fixturing needed. We were at that time, the Gulf War was in full swing.
What's that? 01?
Well, no, it was a little later. Well, I guess the Gulf War was kind of subsided, but we were going back into Afghanistan or Iraq, and so our truck production was going to increase from like 12 a day to 20 a day to 28 a day. We had a schedule, and so to keep up with that, we knew we needed to automate.
Yeah, well, it was good times. And then since then you've gone on, and now we're still working together, right? You're not a customer, but we're both involved in cladding for Sauer Service.
Most definitely.
And that's a key technology if you're going to drill oil wells now. What was it you told me once? All the oil that's left, it's so deep that the pressure, temperatures.
So I told you that, Dan. This is prior to fracking and directional drilling, right? So
Which is mostly land based.
Which is mostly land based. And so at the time, I said, all the easy to get oil is gone. We've gotten it. Now we're going to deeper water, deeper formations. Those deeper formations have much higher pressures and much higher temperatures. So by high pressures, I mean from 5,000 psi or 10,000 psi. Now we're moving to 15,000 psi or 20,000 psi formation pressures, and the temperatures are going up too, from maybe 200 degrees Fahrenheit to 250, and now up to 300 degrees Fahrenheit and higher. And so as you go higher in pressure and temperature, now your partial pressure of H2S causes hydrogen sulfide, right, becomes a bigger problem. So now you're looking at Sauer Service applications.
And what's the problem with H2S? I mean, it's the same thing getting rotten eggs. How could that be bad?
Yeah. Well, once you get beyond the partial pressure of H2 0.05 psi, you get into Sauer Service. In Sauer Service, now you have hydrogen sulfide stress cracking issues. And so,
walk us through that.
Yeah.
So, how's it happen?
Yeah. Well, it's boils down to the hydrogen that's in the hydrogen sulfide gas, and so now you've got hydrogen sulfide stress cracking. You've got hydrogen embrittlement issues. As you're using, high pressures, you need. If you're using carbon steels, you need high-strength carbon steels. High-strength carbon steels are susceptible to hydrogen-induced embrittlement and hydrogen-induced cracking.
So it's H2S will corrode the steel, and in the process liberate free hydrogen, smallest atom, goes right into the crystalline structure of the metal, correct?
That's correct.
Okay, and then 2 hydrogens come together, form H2, and it's actually gas pressure inside the metal crystalline structure that's causing these catastrophic failures.
That's causing a hydrogen embrittlement, yes.
Right. So these parts will crack under no load.
Some residual stresses are required.
Oh, I see.
And so with residual stresses that are from typically from fabrication, welding fabrication, high strength steels or carbon contents that give you the high strength. Now you're into a hydrogen induced cracking or a hydrogen embrittlement scenario.
Okay, so how does, so what we've been working on together or working on in the same field is a welded overlay.
That's right.
And if I understand correctly, the welded overlay has no iron or minimal, less than 5% iron. And so that eliminates the possibility for the H2S to combine with the iron.
The nickel alloy, the industry typically uses an alloy 625 as a weld cladding or a weld overlay, and that will be the barrier to keep hydrogen from embrittling your carbon steel.
All right, and that, if I understand correctly, that alloy was actually originally a nuclear alloy. That's why there's some columbium and some other things that we have no real use for in the oil field.
Mm-hmm.
That's what some of the people have told me. But then we're stuck with the alloy now, so we got to meet chemistry.
And it has performed very well for us. It's
well, the lifespan's infinite, right?
well.
You're not going to go that far.
I'm not going to go that far.
Years.
Years, right. So one of the things we use that quite a bit subsea on our subsea production systems.
Because you can't go down there and change
And
the valve.
that's exactly what happens is we design these systems to last 20, 25 years. The design lives are increasing. They're wanting to push that out to even maybe 30-year design life. That means you put a piece of equipment subsea in thousands of feet of water, and you've designed it and expect it to produce literally thousands of barrels of oil per day, where you can't inspect it, or it's difficult to inspect. Repairs mean you have to retrieve it.
That's hundreds of millions of dollars.
Exactly. It's very expensive. And so this equipment has to be built correctly. The quality levels have to be very high. And to meet these extreme, and I'm going to call 20 or 25 years plus extreme design lives under those conditions. There's not many products that are built that you would expect those design lives without some type of inspection, repairs, intense maintenance.
No, it's been a great solution. I feel like the industry's done a fine job. So we have had failures though out there.
We have had some failures, definitely.
I was thinking of Thunder Horse.
Yes. So BP Thunder Horse was an issue. That was I'm going to call it a new failure
Right.
recognized in the industry.
That's why I wanted to bring it up, because if I understand this correctly, and that's why we got the doctor here on, I kind of traced that one back to NACE changing from Rockwell hardness to Vickers hardness, which meant we had to increase our post-well stress relief cycles, and in the process, that created other problems.
Yes.
Am I close?
You're very close. Actually, we say that there were multiple factors
Always is.
that added up, right? So we put multiple barriers in place. And on the Thunder Horse example, there were multiple barrier failures. One is that we put a coating and then an insulation over the components. Well, those coatings, the insulation had cracked, and it caused the coating to be pulled away, exposing bare metal to the environment. And under cathodic protection, that generated hydrogen, right? So now you've got a source of hydrogen.
It wasn't from the H2S this time, was it?
But not this time, because those failed prior to being put into production.
No oil was spilled.
No oil was spilled. That's correct.
Yeah, we were all fortunate.
Yes, but so that was one barrier that had failed. Another was that we had, and so there was no oil in the system, right? These failed under hydro test. So what had happened is, and you are correct, the industry went from Rockwell C hardness requirements to Vickers HV10 requirements, which mean that which is a little more stringent a requirement. And so to get there, we were seeing longer post-well heat treat times.
Which normally makes heat affected zones softer.
That's right.
But under these unique conditions,
Under these very unique conditions, and it was down to actually the weld bead placement on butter welds, meaning welds
that's
that
why I'm bringing it up. I think
Yeah.
there's a lesson here.
there's a huge lesson here, because it was prior to that failure, the industry didn't recognize the significance of the weld bead sequencing that went into making these welds. And so what happened is the weld bead sequence that was used that caused the failures. Actually, that thermal processing of that heat affected zone caused a very thin, high hard region.
Right.
It's very thin. You wouldn't find it even in typical hardness testing.
Right. It's so small.
It's so thin. Then the extended post-well heat treat times caused carbide precipitation to that region that made the problem worse. So now you've got a susceptible microstructure in a very hard region. Now you've got, you add that to hydrogen from cathodic protection
Right.
that on exposed metal to the subsea environment. And now you've got a hydrogen embrittlement or hydrogen cracking issue.
I know it ended up costing the industry billions of dollars to fix, but aren't we fortunate that the only thing you spilled was salt water?
That's right.
And everybody
That's right.
learned from it. Industry changed.
That's right.
That's impressive to me. That's how we get smarter. Is so, rather than that's why I like talking about these
That's
things.
right. So we've put a lot of mitigations in place. Where the coatings and insulations, we made them more robust, so we don't have those failures. The industry
welding procedures,
the
changed
industry have
wires.
moved right from a alloy 625 buttering now to a carbon steel butter. We've qualified those so that now we don't have that very thin, very hard region that is susceptible to the hydrogen embrittlement.
Well done. By interdicting this before we ever had an oil failure, that's great. All right, so let's go back to this high temperature, high pressure. I think this is fascinating. If I understand it correctly, you guys are finding oil that is at temperatures and pressures which is beyond what we have the technology and materials to produce.
That's right. So there are people pursuing this. There are high temperature, high pressure, high temperature formations being produced, but the problem is that as the temperatures go up, as the pressures go up, these pieces of equipment become thicker and larger and heavier, and now you've got to build these. You've got to take them offshore and deploy them. And it's a real stretch for the material that we're trying to use. It's a stretch for the fabrication of these very heavy, thick section components. It's difficult to install and connect these. So it's a real challenge.
And correct me if I'm wrong, but I believe you were explaining to me that the sections are now so thick that you can't assume equal stress through the entire section. Okay, whenever I calculate loads, I assume that it is equal across the whole section. That's not true.
That's right. So there's the design methodology has to change some. And because of that, it causes equipment to get bigger, bolts to get bigger, larger diameter. Now it just is it's really pushing the materials that we use in our industry and even the design to go larger in all these cases.
But you can't just throw metal at it.
You just can't throw metal at it.
Yeah.
That's right.
Yeah, that's fascinating to me because that's usually what you do, just double the thickness.
That's right. Make it thicker. Make it heavier.
Well, this plays into my world, right? Because you guys can't find a single material with the properties you need, so you need to start combining material properties, which is the whole point of welding overlays. So it works out well for me.
That's right. Yeah. So weld overlay has been the go-to to solve a lot of these problems. You'll see that in the high pressure, high temperature space, but there'll be other technologies that will have to be utilized to solve that problem.
I know at one point the industry was playing with hot isostatic pressing of the inner layers. That's didn't work at the time, but
Right.
everything gets a shot.
And we're using super duplex that's hipped or high isostatic pressed in some cases because of the high strength that super duplex affords us. The problem is that super duplex adds to the complexity of the fabrication. Now that you've got to weld these components, it means a lot more control for fabrication.
Because you're using nitrogen, right? That's part of the super duplex.
That's
So
right.
you're making metals out of gases. It always blows my mind. And so you've got to keep the gases in there, and we're doing that with some shielding gas, but I think you're limited to less than 0.5%, something like that.
Well, less than 2% definitely, but it's usually around the 1%.
1%.
Yeah.
And the gas wants to go back into the environment. Fascinating stuff. So I'm hoping that there's somebody out there that might get interested in this, because I find this field fascinating. You've got the art and the science of welding, material science, metallurgy. Fascinating to me. And for somebody going into the industry right now, you and I are going to retire in a while, not too long, I hope. But there's some fascinating challenges lying ahead for the next gen.
Most definitely. I'll tell you, this is a challenging time. There's several things at play here. One is in the oil and gas industry with going to this high pressure, high temperature. Another is introducing additional technology for carbon capture, emissions reductions in the oil and gas industry. But then the oil and gas industry is going through quite a bit of energy transition, which brings a lot of additional challenges. Moving to hydrogen transportation and storage is probably one of the bigger challenges that was being addressed right now.
We have some experience with hydrogen, so that'll all apply. Well, I was at a conference this last week, and they pointed out that an electric car has twice the amount of plastic, which is petroleum-based, than an internal combustion car. So, even if we're not using petroleum as a fuel, we haven't replaced plastics yet. So
most definitely, the petroleum is going to be around a while. There's a big push, of course, for the energy transition to get away from petroleum, but petroleum's going to be with us for quite some time.
You can't beat the energy density.
That's right.
Right. Next time a jet flies, the only way we're able to do this currently is with kerosene, which is petroleum based.
Yes, we are seeing some biofuels being introduced into the into the.
But these are still hydrocarbon fuels.
But that's right.
Just depending on where you got them. Mm-hmm. And same thing with hydrogen. I think a tiny percentage of the hydrogen is actually green.
That's right.
Most of it's generated from natural gas.
That's right. So I will agree with you that right now is an exciting time in the energy industry, because of all the activities, all the technology that's needing to be developed and implemented to meet emissions goals, to meet the energy needs of a growing world. There's a lot of the world that's is still going to need petroleum-based energy. It's going to need all types of energy. And so
I read once that for every calorie of food you eat, there were 10 calories of fossil fuel that went into the production. So as long as you're going to eat, for the foreseen future. Hey, yeah, you walk around our shop all the time. You come and visit, and you just saw our latest success story, which was the riser robots, which are on drill ships. I don't think they're on yours. They're on, I suppose, your competitors. But on the drill ships, and they're running riser, trying to get people out of harm's way, finally putting robots in drilling. But we're started on the hard stuff, which is offshore. But we just won a System Innovator of the Year award for that.
Yes, congratulations on that, Dan. That is a huge award to win for all of the robotic industry, but much less for someone to take a historically, oil and gas has historically not used robots, but to take a robotic application in and apply it to an oil and gas industry that has been a bit hesitant to move into automation,
Yeah, you guys are
even makes it a better prize for our specialties.
Oh, yeah, and I was delighted. Of course, I find it ironic that our first Robot Innovator Award was for bolting rather than welding, but that's
Yes.
okay. But,
Yes.
I want to talk about, I mean, that's always been the goal in the oil field. They always claim that the ultimate drill rig will have a dog and a man, and the dog is, no, the man's there to feed the dog, and the dog's there to bite the man if he touches anything. I know that's your ultimate goal, but
That's about right.
yeah, but you guys are not getting too close to that. You know, it's been hard for us to break through and get this first set of robots on the rigs.
Yes. But you found the right application, I think, is because where you're putting this is onto the drill, what we call the drill floor, and that is the most hazardous position.
The red zone.
The red zone. There is quite a bit of material movement, tubular pipe movement there, and this when you go in to drill a well, and all of that is big, thick, heavy section. If something breaks, something moves when it's not supposed to, people can get hurt. And so that makes sense that to take people out of harm's way and to do this robotically, I think the biggest thing is safety. You've taken the human factor or the human out of the hazard zone. The next thing is repeatability. I think that you'll see huge gains in success in the repeatability that the robots will gain you. I think you'll see the ability to operate around the clock or in hazardous weather that may have shut down human operations at that time. And so there's quite a bit of advantage that bringing robots to the drill deck or the drilling floor have provided.
I just think it's ironic. We've been building stuff for the oil field for 40 years, and only now are we on the drill rigs. But it's been fun. Extremely challenging environment you guys are working in, by the way. So you're out there floating around in an ocean, and you are 2 miles above the ocean floor and then several miles above the oil deposits.
That's right. It is a challenging environment because of the remoteness, because of the water depth, because of the weather environment, because of the corrosive environment of the salt water. It is a real challenge. And we're seeing automation being used. But one of the challenges is getting enough people out and on site to do the work safely. And if we can use automation to replace people and to do it more efficiently, you'll see that the acceptance of robots will be, or people will be more accepting of robots.
Well, we're having fun, and what we're doing is finding out that a lot of the robot technology, like that you and I used to weld up tactical vehicles way back in the early 2000s, it's the same technology to use offshore. You know, why not capitalize on 40 years of robot success? So
that's right, and I think some of the advances in robotics have been helpful.
Undoubtedly, we're using saw float, we're using machine vision, we're using laser scanning, we're on and on, high-speed communication. You know, if you'd have given me this job, and this isn't for you guys, but if they'd have given me this job 10 years ago, we wouldn't have the tech. So that's why we try to stay constantly abreast of the new technology so we don't become dinosaurs. But it's working out okay.
I applaud you for that, for it working out as well as it has, because it's. I think it's huge. It's the safety implication alone is well worth the effort.
Well, but we're also saving them money. So that, what's rig time? I'm hearing numbers between 1 million and higher per day.
Most definitely.
Yeah,
right. So the rig itself is easily $1 million a day. You get all the supporting watercraft and support crews, and you add all this up, and it's extremely expensive.
How in the world do y'all keep gasoline down below $4 a gallon? I don't understand. Okay, so we also we do some stuff on the side, and you called me not long ago for canoe instruction.
That's right.
And I'm a huge fan of Boy Scouts, if they've got good scoutmasters, and I count you among the good ones.
Well, thank you, Dan. Dan is a master of many skills, and so when my Boy Scouts want to learn to canoe or to kayak, I call on Dan, the master instructor. And
we had too much fun.
We had too much fun, and when I always ask, even today, I ask those boys, what they enjoyed the most, so we can do it again, right? Or so the next crew that comes along, we can do, and that's right up there at the top of the list. Oh,
we got to do it again then. Let's host another class. We'll just push it a little harder.
Let's do it. Let's do it this spring before it gets too hot. But yes, we had a great time out on a small lake, learning canoeing skills and paddling skills, and then after Dan's instruction, we went on a trip to Arkansas, the Buffalo River, and we did over 50 miles on the Buffalo River.
And everyone survived.
Everyone survived, had a great time. Dan taught us some safety, or had some safety talk about flipping over or going through trees called strainers. We had an incident where 3 of our canoes with scouts in them went through a strainer, and they all popped out A-OK, and we salvaged
good
the
to have
canoe.
to make that stuff up on the fly. No, that's why we talked about it. Yeah, I'm glad everybody did well.
That's right. So it was
be
wonderful.
Deadly.
And we need to do it again. It's a good time.
I'm kind of pushing Boy Scouts here because I
Yes.
think it's a great thing. You obviously believe. How long you been a Scoutmaster?
I think it's a great program. My 3 sons went through. I've been a scout.
The Eagles?
2 Eagles. My oldest son, he found some other interests that he moved on to, but my 2 younger sons both Eagled.
Well done.
And thank you. And the program really is good. I'm out in Sealy, Texas. We have a small program, but we've got great scouts, good parents. We do a lot of great activities, a lot of community service projects. I'm real proud of the scouts in the program itself. And so I've been Scoutmaster for about 13 years now, and hope to be for a few more years. I tell the troop that the troop deserves an energetic and gung-ho Scoutmaster, and when they see me slipping, to kick me out, kick me up a notch, or to kick me out, and then I'll support from a different viewpoint. But scouting is good when you have an active troop that is really learning about life skills, supporting community with community service projects.
Oh yeah, we've done some signs for the VFW Hall. It's been more than just paddling.
Most definitely. So Dan's been a huge supporter of my scouting group and the group that I work with at the high school, the welding group at our local high school.
That's just because you're always digging in the dumpster and pulling metal out for the kids to weld.
Yeah, but so just real quick on the sign you mentioned. So one of my Eagle Scouts, his project was to freshen up the American Legion there in Sealy. We wanted to put some landscaping in, and the sign they had was in terrible shape, all rusted and in pretty bad shape. So I asked Dan if he'd cut us out a new sign on his
got a computer cutting machine. That was easy.
It turned out beautiful. The
hard part's installation.
Yeah, well, about 4 scouts and I, one Saturday afternoon, we tore the old sign down and cleaned it up. Cleaned up the posts and put the new sign up. And it's interesting. That sign is just, everyone wants to know where the new sign came from. How did we get the new sign? What happened there?
Don't tell them.
I know that's a secret. But it was interesting. The next week, the American Legion got the Sealy newspaper Yard of the Month, and it was all because of the new sign, the fresh coat of paint, a few little rocks around a flower bed, and so the American Legion's really proud. I'm really proud of the Scouts. We're really grateful for Dan and Arc Specialties for helping us out on that project.
Oh, I'm always happy to help. No, that was definitely a good project. I want to talk a little bit about welding engineering. We actually, we have endowed a scholarship. It's a great field, but it's almost unknown. So, you're living proof that a degree in welding engineering can lead to a fascinating job and a great career. So, talk to the kids out there that might be thinking about this.
Yeah, no, that's exactly right, Dan. Welding has been an excellent career for quite a few people I can name. And I think what happens is that when people think of welding, they think of, some guy working in in the ditch welding a pipeline, or some guy
And that's part of it.
putting mufflers on cars, and most of the kids today are interested in computers and high tech things. What they don't realize is that welding is high tech. Welding is complex metallurgy over short distances and high temperatures. It's you're dealing with solids, liquids, gases, and plasmas.
4 states of matter.
That's right. And so welding is definitely its own discipline, engineering discipline.
Let's talk about the schools. So you mentioned
Mm-hmm.
2 of the, there's only a handful.
There's a handful. So I was fortunate. Texas A&M had a welding and metallurgy technical elective program attached to its mechanical engineering program, and that's the program I went through.
Is that Dr.
Unfortunately,
Price?
that's Dr. Angie
Dr.
Price.
Angie Price.
Unfortunately, they've discontinued that program for the most part. They call it manufacturing engineering, and Dr. Price does a great job with the courses she teaches still there. But most of the graduates out of that program that took the welding and metallurgy technical elective program went to work as welding engineers. And they did a good job.
Mm-hmm.
If you look at LeTourneau University in Longview, Texas, they have a welding engineering program that's an excellent program. It's a relatively small program with not many graduates per year, but I'm very impressed with the program, very impressed with the graduates. I work with them throughout at different companies throughout our industry, and definitely a good program. They are very wise in that they do both the hands-on part
Awesome.
and they do the theoretical
And that's
part.
why we've endowed the scholarship with that group. And I've had a couple of professors that were instrumental in my career that came from LeTourneau. So yeah, I'm a fan.
As am I. I've not taken any courses there, but I am definitely a fan of that program. And then there's the Ohio State University.
Well known for welding engineering.
Well known for welding engineering. Mostly theoretical. They do put students through a hands-on laboratory to expose them to manual welding processes, but there's no real requirement to be proficient at welding as there might be at LeTourneau. But excellent program. The Ohio State University is, of course, up in Ohio, in the Columbus, Ohio, there in the Rust Belt. They recognize the value of welding engineering in automotive industry, heavy equipment industry.
Right next to the Edison Welding Institute, America's think tank for welding.
That's right.
I think the kids are involved in that, right?
There's quite a few. The professors are definitely involved with co-sponsored projects. A lot of the students there do get internships and part-time jobs with
You
the
did.
Edison Welding Institute. And I did as well. I had finished up my master's degree and had been working for the Edison Welding Institute as a student worker, and they offered me a fellowship to continue my studies towards a PhD. And so I went to work at the Edison Welding Institute, and that was a way that I could continue my education, and they sponsored my project, and it was really it worked well for both of us.
Let's not lead about the other guys. There's Ferris State.
That's right. No, definitely would like to talk to Ferris State. Impressed with their program too. They're
Where's that located?
excellent. I'm trying to call the
Okay.
right there in Michigan. I'm trying to call the city there in Michigan. Excellent program. Very heavily into robotic and robotic programming.
I like it already.
Very good hands-on, manual welding program is my experience. And so I think quite a few of those people that graduate from there go into the automotive and
Right. They're right
the
there.
heavy equipment manufacturer that's prominent in Michigan, Indiana, Iowa, Ohio, Pennsylvania. that area.
We missing anybody? I don't want to lose it.
I think there's some smaller programs out there.
Hit the big ones in.
Yeah, definitely some junior college programs that
absolutely. All over the place.
smaller programs. But I think we've hit on the major.
Great career though.
Most definitely. I think I said earlier it was a way I could turn my hobby into a career, and that was really appealing to me. And I would encourage others to look into welding engineering. One of the things that it's unique, right? There's literally thousands, I would think, of mechanical engineers that graduate every year.
How many
civil
welding
engineers?
Less than 100?
Definitely less
than 100 a year.
Definitely, right, because you're looking at, I don't know, 10 to 15 maybe a year from LeTourneau.
So maybe under 50.
20 to 30, or I would say 25 to 30 a year from Ohio State, plus graduates, graduate school graduates, maybe another 10.
I think the Kimmies make a little more money than you guys, but
yeah,
right out of school, but y'all are way up on the food chain.
That's exactly right, because of the uniqueness, right? I would say that the Houston area could absorb all the Ohio State graduates that
we absorb a lot.
A lot of them come to Houston for the oil and gas industry or the aerospace industry that's growing here in
we have
South
one on
Texas.
staff right here at Arden. Well, it's been a great career for me, and I think you too. What do we miss? Anything else you want to cover? You can always come back.
Yeah, no, I'd like to come back sometime. I do want to say, Dan, I want to thank you for being a supporter of, because I enjoy welding. I enjoy working with students that do welding in the local Sealy High School. I enjoy supporting their welding program. Dan's been gracious. I come by and he gives me the drops off of his plasma table, and it's like Christmas Day when I show up out there with whether it be welding electrodes or materials for them to weld on. Or
what do they say? One man's trash is another man.
That's right. Or I'll be trying to sponsor a small project with the high school students, and I say, Dan, I need 4 foot of square tube. I don't want to go buy a whole stick. And Dan's always gracious. He always says, come get what you need. So
you got the hard part of that job.
I really appreciate you supporting, because I think that's what happens if we support these youngsters, whether they be high school or where it may be. If we support them in welding and robotics, and as you do with the robotic skills competitions, I think that's what's going to ignite their interest in welding and manufacturing, and to carry them through whether they just decide to go to the university or go right into welding.
Absolutely. And it's no longer welding under a hood. We're programming robots using electron beams. We're welding with photons. It's pretty technical nowadays. Well, how many countries have you traveled to, Doctor?
I've with the oil and gas industry, I've traveled to quite a few. I can't. I don't know.
I added
Norway,
it up the other day.
Finland, Sweden.
I'm at over 30.
China.
Never would have thought.
Japan.
It's been
Singapore. It's just quite a few, and it's because the oil and gas industry is
global.
Is global. That's right, and there's work being done all over the world that to support equipment being built, pipelines being built all over the world to support oil and gas, and so we go where the work is.
Absolutely. Appreciate you coming on today. As always, when we talk, I learned something.
Well, thank you, Dan. Thanks for you and ARC Specialties for inviting me. I enjoyed it.
Get you on soon. Thank you.